Okay, and welcome to question 5 of the 2017 paper 1, and we're looking here at a trapezoidal rule question. You've got trying to find the area under a curved shape, okay, and you give the diagram. So it's a kind of bog standard question. So let's read through it. A field is divided into 8 sections as shown below. The width of each section is 3 meters. Okay, that will be your H. And as you're going through a question, if you see anything that you recognize, like label it or put it on the diagram, that will qualify you for usually the low partial. In this question is the 10C scale. So you have low partial, high partial, and full grade. Anyway, the height in meters, now they use the word height there, we should say width when it's a field, but the height in meters of each section is given in the diagram. And that could confuse you by thinking the H and the height are the same thing, but in the trapezoidal rule you'll see here on the bottom, H is the interval between each division, and it should always be uniform. Now they tell you exactly what to do. Use the trapezoidal rule, which is in the maths tables, to estimate, and you'll never make an exact value of the area of the field because of the fact that the trapezoid rule and the Simpsons rule, which is a similar rule, are just estimations, approximations. The only way to get the exact area would be to use the process called integration, which is not something that's covered on the pass level leaving cert. So let's go to the answer, okay, the next page. So I've given the formula here. Now it's the same as the formula down here. It's a slight different adaptation in that I just ran out of space here, so I dropped off the y n plus 1. So it just indicates that, you know, this triple dots that goes on and on until basically the second last y value. So y1 is the first value, yn is the last value, and you have y2, y3, y4, y5, whatever, all the way, depending on how many divisions there are in the particular question. But from the diagram, the h is equal to 3, y1 is 4, so you see that there, y2 is 5.8, y3 is 6.5, y4, etc. Okay, so you're trying to fill in here, I've done it here, it's pretty small, but, okay, your h is 3 over 2, so that's there. First is 4, last is 8, that's given here. Then you have your twice all the other values, so twice 5.8, twice 7, twice 6.5, twice 6, twice 4.8, twice 6 again, twice 6.5. You stop there because you already have accounted for the last in the beginning of the formula here. And you close your brackets. Now, if you program this in the calculator, okay, this entire block here as such, okay, you can go straight to the answer, okay. It's just you want to be careful that you have the brackets in the right place. So if you put it in exactly like it is on the screen here, you come up with 145.8 meters squared. It's always very important to include units. There usually be a mark taken away, and to not round too early if that situation occurs. So that's the approximation. Now, I've actually used the wrong symbol here. I should use the approximation symbol, like up here, but look, I'll be forgiven for that. Now, the next thing of the part B here is a 15-part mark scale, 15D, so there's a low partial, mid partial, high partial of 10, and full marks of 15. Now, let's read through the area of the same field was re-estimated by applying the trapezoidal rule again. This time, a different section, 4 meters, so the interval here is changed, and a different set of section heights were used, as shown below. The area was found to be 145.6 meters squared. So say use this information to find the value of the height marked x. So in this case, okay, normally in the first part A, our unknown was the area. In this case, the area is given, and our unknown is just one of the heights. So it is an equation of one unknown. It's just the unknown's not going to be like tidily on its own. Let's go to the answer. Okay, so again, that's the trapezoidal rule just written up here. So I filled it in. Okay, so 145.6 equals the new interval of 4 over 2, multiplied by first plus last plus twice everything else. Now that x is included in the everything else. Okay, so 6.4, 6.9, 6, x, and 6.2. So if you look at it here, okay, your unknown is an equation of one unknown. If you just, I suppose, you could do different ways, but reduce it down. I'm going to have to kind of do it piecemeal because of the way the thing is. So if I added these numbers in here, 6.4 plus 6.9 plus 6 plus 6.2, that gives me this 25.5 here. So I've kind of collated those bits there together. I've also at the same time done this, so 4 over 2 is 2, that's where I get this 2 here. This 4 plus 8 plus 2, is 12, okay, that's the 4 plus 8, and then 2 times what was in the bracket, that's reflected there. So basically what I've done is a little bit of simplification as I go left to right. Now I come along and go, well, let's remove brackets, so I'll remove the internal brackets here first. So 2 times 25.5 is the 51. The next step now, I'm going to multiply 2 all the way into that bracket. Okay, so 2 times 12 is 24, plus 2 times 51 is 102. 24 plus 102 is 126. And I've doubled the 2x, so 2 times 2x is the 4x here. Okay, so again, it's just algebra. You're simplifying down to get to your answer. Now I can bring this 126 across the equal, or the approximation. Okay, and just like any algebra, it was added on the right hand side, so it becomes subtracted on the left. Do that little calculation, I end up with 19.6 equals 4x. Okay, now I haven't gone to the answer for some reason. Maybe it's just off the page actually. So if I brought the 4 across, I'm going to end up with 19.6 divided by 4. The 4 was multiplied in the right. When it comes across the approximation, it becomes the opposite of being divided. And that's equal to your x. Put to the calculator, and you're going to end up with 16. You have to put the calculator up. Let's see now. So that would be, we said 19.6. 6 divided by the 4. We'll end up with 4.9. Okay, so 4.9 equals the x. Okay, and that's my answer. And if you even look along the diagram, 4.9 is significantly lower than the 6 and 6.2, which, you know, passes the BS test. And that should be it. Okay, so that's it for question 5. Thanks very much, and see you in question 6.